Okay, in this video we'll talk about MATLAB functions. Specifically, we'll talk about user-defined functions in MATLAB and so MATLAB has some built-in functions which you've used before, like plot, for example, or sum, which specifies some specific input you give it and then returns some sort of output, right? So, for example, if you say usually you have X is an array of So usually X is just some set of data. Similarly, Y is another set of data, right? Points. And then if you go plot X comma Y, MATLAB will generate a plot. So this is a built-in function in MATLAB, where it basically takes some input and returns some output. So similarly, you can create a user-defined function, which is a program that can be used just like these built-in functions, where basically it will take some user input, performs some calculations using this input, and provides some results in the form of an output. And we'll talk about how to create such functions and how to use them, and the general form of these functions. Typically, you write these functions in a script. So if you're gonna basically, let's close out of all this junk here from all the previous homeworks. Okay, so usually you start a new script, and to write a function, you write the word function, so it's usually function, and as you see, once you write it, turns blue. Um, and this is the keyword function, and then between brackets, you're gonna specify your outputs. And you have to be careful. On the left hand side, your outputs will be between brackets, so I can say out1, out2. So for this case, I'm just creating a function which produces two outputs, and then so keyword function, square brackets, the number of outputs you want, and then equal sign. On the right hand side, you're gonna use the function name, and this function name could be anything you want to call it. And then in parentheses, you have your inputs. In this case, I'll just use N1, N2, etc. And you can have as many outputs or as many inputs um, as you want or as you need in this function. It's important that the function name you give your function here has to be the same as the name you use to save this file, so that you are able to call this function in the command window and execute it. So if I'm calling my function name, when I go to save it, I have to save it as function name.m, right? So the file should always be saved using the same function name you specify. Um, and Another thing with that is that when a function is called in the command window, um, any values you provide as input will be saved in the location of N1 and N2, um, and they will be stored inside the function under these variable names. So if I'm going to write some code to execute or to run a series of commands, I can use N1 and N2 in place of the input which will be provided by the user. So let's start do an example. I think it makes things easier. So for example, let's write a function that finds the maximum value of an array. Okay, so basically the user will provide, if the user has an array and he wants to find the maximum value in it, he'll just call this function and the function will return the maximum value of this array. So let me just comment this, and let's start by writing the function. Again, your keyword will be function, and the output will be the maximum value in the array, so I'm going to call it max value, and this is the output which will be produced from this function, and this will be equal to the function name. So what do I want to call this function? Let's call it find max array, right? You can call it anything you want, but this is the name I'm giving it. Another point when calling function names, so usually you don't want to call the function something similar to a MATLAB function, right? So for example, if I create a function called plot here, so if I call this function plot, you're gonna get an error because MATLAB has its own built-in function called plot, which is used to generate a graph. So when you create a user-defined function with the same name, this will cause you errors in MATLAB, or it might even overwrite the plot function in your directory, and then you lose the ability to use the plot function. You might have to reinstall it from MATLAB. So be careful with the names. Try to use a unique name which is specific to your task. So let's going back. So I use the keyword function. Max value is the output. Find max array is my function name, and then between parentheses I'll have my input. So I'm gonna call it array in. Okay, so array in is the input, and max value is the output. And if I want to, so after if I want to call this function the command window, I would just write find max array, which is the function name, and then I'll just specify the input, which is the array. So for example, 0, 1, 5, 4, minus 15, whatever. And then when I execute this line, I should get a return or an output with the maximum value, and it's undefined because we haven't really saved it. So let's go back to the function window here, and let's write the code or what we want to execute. So first of all, I'll write n, which is length of array in, and the purpose of this line is to just find the length of the input array, and then I'm gonna just do our typical finding the maximum value, similarly to what we did in the previous homework or a couple of previous homeworks. So I'm gonna say max value initially is minus infinity. So when you want to find the maximum, you define it to minus infinity. When you want to find the minimum, define it to plus infinity. And then I'm going to use a for loop for I equals 1 to n if array underscore in of I greater than max value, then max value is equal to array underscore in of I, right? And then end, and basically, as you can see here, we just wrote our body of the function, and you have our if else statement, and here, so basically I'm looping the entire array which is provided by the user, and then I'm checking every value versus minus infinity. If it's greater than minus infinity, it becomes the new maximum value. I move on to the next one, comparing basically the second value to the first value, etc., until I exit out of the array, and the loop and the output will be stored in this variable called max value, which is the output of this function right here, maximum value, and this is what the user will see. So let's try and test it. So I'm gonna save this. It will ask you to save it. So again, you need to save it using the same name. So I'm gonna save it under the name find max array, save, and you can see here the function name is findmaxarray.m, which is the same name on the right hand side of the function command. So if I go to my command window and I try to implement this, so I'm just gonna copy this line we wrote a few seconds ago, find max array, and I'm gonna run it, and as you can see, it returns the maximum value of 7. So it's able to find the maximum value of 7. we're getting a bunch of results here because we did not suppress it in our function. So let's suppress the loop in the function so it's not showing me all of its internal thinking. I just want my output product at the end. So I'm just going to suppress the line in the function. I'm going to resave it. And then let's go back here. And I'll just call this function. So find max array, it will just return the maximum value of this array. You can test it with any combination. 200 minus 900, 1.567. It will always return the maximum function. And this basically gives me the ability to do this many times just by calling the function find max array. So this is a very useful tool. As an engineer especially, we tend to repeat calculations. So once you understand the fundamental science of any application, you want to repeat the same calculation multiple times for many different scenarios, and having the ability to create a function that can just replicate this calculation many times is a very powerful tool for you to have.